Very good morning to all of you students. Welcome to the physics class. In this session, we will discuss chapter number 3 of class 11th, and the name of chapter is dimensional analysis. In this chapter, we will discuss a new method of finding the units because we study only there are some system of unit, but here in this chapter we will discuss a new method and new representation of any physical quantities units. Okay students, so starts. First of all, I want to tell you what is the definition of dimension. So dimension of a physical quantity are the powers to which the fundamental units are raised in order to obtain the derived units of that quantity. It means that in this method we use some powers, and these powers are raised on some particular letters, and by putting these we get the units of any physical quantity in different manner. Okay students, so first of all we have to understand the fundamental quantities, because this method is generally depend on the fundamental physical quantities. Because if we don't know the symbol of fundamental quantities, then we cannot find out the dimension of any physical quantity. So student, here we will find and calculate the dimension formula of some physical quantities which are important according to your examination. So first is area. As you know that area is not a fundamental physical quantity. It is a derived physical quantity because it is formed with the help of a fundamental quantities. And we know that length into breadth is equal to area. So we use capital L for length and capital L is for also breadth. So here we see that m to the power 0, L to the power 2 and T to the power 0, where m stand for the mass, T stand for the time and L stand for the length. So its dimension formula will be m0 L2 T0, and its SI unit is meter square. In the same way, we can also find the dimension formula of density. We know that density is equal to mass by volume. So mass is a fundamental quantity that which we can put capital M here, and volume, that means length into breadth into height. It means L power 3. So the dimension formula will be ml minus 3. We can also write here ml minus 3 t 0. Clear students? Now dimension formula of acceleration. So acceleration means change in velocity upon change in time, and velocity means length upon time, that means distance upon or velocity upon time. So we can write here L t minus 1 upon t. It means m0 L t minus 2. Force, it is important because we generally use the dimension of force for finding the other dimensions. So you have to learn here force. So force means mass into acceleration. That means m into lt minus 2. So its finally dimension formula will be mlt minus 2. Clear? Okay student. Now student, we will discuss here only the most important dimension, because number of dimensions are here, and if we discuss all the dimension then our video becomes very long. So we have to study only the most important dimensions and their applications. Clear out? Okay, linear momentum. So linear momentum is mass into velocity. So we can write here mlt minus 1. Now potential energy. Potential energy is mass into acceleration due to gravity into h. That means u is equal to mgh, and mass means m, and acceleration means lt minus 2, and height means l. That means m l2 t minus 2. Now moment of force. Moment of force is equal to force into force r. So we can write here mlt minus 2, which is the dimension of force, and l, which is the dimension of length. So ml2 t minus 2. Student, There is an important point here. The dimension of work, dimension of moment of force, and the dimension of energy, these all are equal. So you have to learn the dimension of these three physical quantities are equal. Okay, student. Now, stress. Stress means force upon area. So the dimension will be ml minus 1 t minus 2. Okay, student, the dimension of coefficient of elasticity. It is equal to stress upon strain, and we know that the dimension of stress is ml minus 1 t minus 2 upon l0, because strain is a dimensionless physical quantity, means there is no dimension but it have a formula. What is the formula of strain? And the formula of strain is length upon length, change in length upon original length. That means it is a dimension and unitless physical quantity. Now the next one is surface tension, force upon length. So its dimension formula will be m L0 T minus 2. Coefficient of viscosity. Coefficient of viscosity is force upon area into velocity gradient. So its dimension is m Lt minus 2 upon L2 T minus 1. That means ml minus 1 T minus 1. And next one is gravitational constant. It is also known as universal gravitational constant and represented by capital G. So capital G is equal to Fr square upon m1 m2, and its dimension will be m l m minus 1 L3 T minus 2. There are number of dimensions, and we will discuss here few dimensions like specific heat's capacity or heat energy upon a mass into temperature. So its dimension will be m0 L2 T minus 2 and theta minus 1, where theta stands for temperature, a change in temperature. Coefficient of linear expansion, change in length upon original length into temperature. So its dimension will be m0 L0 theta minus 1. Okay, students. And in the last, we will discuss gas constant. It is represented by capital R. R is equal to PV upon capital T, where P means P stand for pressure, V stand for volume, and T stand for temperature. So by putting the values, we get the dimension is ml2 T minus 2 theta minus 1. Now we will discuss here principle of homogeneity. Homogeneity means equality. So as we know that two equal quantities can be add or can be subtract. So in the same manner, if there are two physical quantities and they have the same nature, they define the same thing, then their dimension will be equal and we can add their dimensions or subtract their dimensions. So this is the principle of homogeneity. Here it is defined by the formula Q is equal to W plus X, where W and X are two different physical quantities but the same dimension, means they are representing the same nature, and their resultant is also equal to the same nature. Clear? Now, uses of dimensional equations. There are number of uses by which we are using dimension formula. So first is to convert unit of one system into the other system. Means with the help of dimension, we can convert one system of unit to another system of unit by the formula n2 is equal to n1 m1 upon m2 whole power a, l1 upon l2 whole power b, t1 upon t2 whole power c, where n1 is the numerical value of given physical quantity. For example, 2 joule. Here 2 is the numerical value and it will be considered as the n1. Clear? And joule represent work. So here physical quantities work. M1, L1, T1 are the mass, length and time of the given system, and M2, L2, T2 are the mass, length and time of the calculated system. Okay, students. Now students, to check the correctness of an equation, with the help of dimension formula we can also check the correctness of any equation or any formula. We can also check the formula is correct or not by putting the dimension of both two sides. For example, as we know that half mv square equals to mg, that means kinetic energy will be equal to potential energy. So we can also check the formula is correct or not. So we have to find the dimension of left hand side and the dimension of right hand side. If the dimension of both sides are equal, then we can say that the formula is correct, otherwise it is wrong. Next use is to stabilize the relation among the various physical quantities. With the help of dimension analysis, we can also generate a formula, because we know that in a formula there is a physical quantity and other physical quantities are depend on the main physical quantity. So we can also derive a formula in which there are number of physical quantities are present. For example, expression for the time period of a simple pendulum. So first of all, we know that the time period is represented by capital T of a simple pendulum, and mass of a bob is small m, length of the thread represented by small l, and acceleration due to gravity is represented by small g. And we know that the time period of simple pendulum capital T is depend on mass, length and small g. So we can write here T is equal to m to the power a, L to the power b and g to the power c, where a, b, c are the values which can be determined. And after finding the values of a, b, c, put here and get the required result. So we have to put the dimension of both two sides, and by putting the dimension calculate a relation between ABC and find these values. So by putting these values we get a required relation T is equal to 2 pi under root small l upon g. So this is the formula of time period of simple pendulum. So with the help of this analysis method we can derive different formulas. Okay students. In the last, we will discuss here limitations of dimension analysis. As we know that dimension analysis is very important method and it is very useful for us for finding different things. But there are some limitations also present here. So first limitation is by this method, the value of any dimensionless constant involved in the formula cannot be calculated. It means that if we are calculating any formula and there is a dimensionless constant, so we cannot calculate accurately the value of that constant. So this is the limitation of dimension formula. Second one is in a physical quantity depends upon more than three factors, then we cannot drive the formula. It means that if in any formula there are some physical quantities which are more than 3, then the relation cannot be stabilized very easily. The last, by this method, the equation containing trigonometrical ratios, exponents and logarithm cannot be analyzed, because there are not dimensions symbols are present for trigonometrical ratios, exponents and logarithmic values. So these are the limitations of dimension analysis. But it is very important chapter, it is very important method by which we can different things. So students, learn this chapter very well. This is most important chapter, because in this chapter we learn all the formulas which are used in the whole book. Okay student.